This is 2.7 today. And we are talking about absolute value functions. So as you guys have already discussed, everything today is going to make a V. Okay? So when we work today, everything is going to work in a V. There is a magical, wonderful line down the middle of this V that we call the axis of symmetry. Means that I can fold on that line and each side's going to match up. This wonderful V has a point at the bottom. This point at the bottom is called the vertex. Now the vertex happens to be our letters HK. It's how much it is translating right and left and how much it's translating up and down. That's where our vertex falls. Okay? All of our V's right now, the basic parent function, they have a slope on this side and a negative slope on this side. So for the parent function, the slope on this side is 1 and the slope on this side is negative 1. So we're going to use this basic V all the time. Okay? We're going to be using it, stretching it, flipping it, moving it right, moving it left, moving it up, moving it down. All right, so this is where I want to start. Here is example number 1. I want you to go ahead and put one of those graphs in for example number 1. All right. So, I know. So I said you might want a piece of tape on the bottom. We'll just see. If we don't end up liking them, we don't like them. It is what it is. All right. So let's say I give you a graph of, or a function of y equals the absolute value of x plus 2. Now, the directions in the book say one thing. It says you got to make a table of values, plot the table. No. That's not what we're doing today. Okay? I want you to tell me, how is this translating? What are we doing? What are we doing, Zayden? Yeah, I agree, Seth. So, do I have anything added or subtracted to x on the inside? No. So, I'm just going up 2. I'm going to move up to, right here is going to be my vertex. So my vertex is at the point 0, 2. I didn't move to the right or left. All I did was move up. Okay? Now, my slope is this A value in the front, which is a magical 1. So from my vertex, I'm going to go up and over 1, up and over 1, up and over 1. We're going to go back to our vertex, go up and back 1, up and back 1. And then we're going to connect our dots. And one back. Okay? So all of our V's today, that's its slope, unless there's a number in front. Okay? So today, instead of doing what the directions want you to do, I want you to state how it translates and then sketch it that way. All right, so here's example number 2. Okay, and go ahead and put a second graph in there. All right, this is exactly what I want you to do for 8 through 16. Describe the transformation then graph. So let's say I have y equals the absolute value of x minus 3 minus 1. So what do you think, Seth? Good. We go right 3 and down 1. Up right 3. I forgot my 3. And down 1. All right. So starting at the origin. Right here, I'm going to go to the right 3. 1, 2, 3. And down 1. This is my what? Vertex. Very good. That is my vertex. Now, again, I just have a 1 in front of the absolute value. So on the right-hand side, I'm going to go up to the right 1, up and to the right 1, up and to the right 1. I will go back to my vertex, and I'm going to do the left side. Up and back 1, up and back 1, up and back 1. Connect your dots. No, I just want you to state what the translation is. So this was 10 through, that's supposed to be a 16, or 8 through 16, yep. So there are 4 of these to do. That's the only 4 graphs you have to do today. Okay? All right, any questions so far? Okay, now, I still want you to graph because I want you to understand the next part. So here is example number 3. Put a third graph in there. I didn't do that very straight. Let's try that again. There we go. Okay. Example 3. I want you to state the transformation. All right, and let's say I have y equals 2 absolute value of x. So the 2 in the front means a what? A stretch. I heard somebody say it. It's a stretch of 2. Did I move right or left at all? Did I go up or down at all? So we're going to start at the origin. When we talk about the absolute value, the stretch is like the slope, 2 over 1. So I'm going to start here. I'm going to go up 2 this time and over 1. Up 2 and over 1. Up 2 and over 1. I'm going to go back to my origin. Go up 2 and back 1. Up 2 and back 1. And connect your dots. So you can see that our V got skinnier as we stretched up the ends. It gets closer and closer together. Okay? Let's do one more graph. It'll be the last one I make you put in there. All right, example 4. How about if I have y equals the negative 1/3 absolute value of x? Yep, it's a flip, and we are compressing or compress 1/3. So when I say it's a flip, that means it's going to open down. Okay? So starting at our origin, we're going to do our slope. Down 1 and to the right 3. Down 1 and to the right 3. Down 1 and to the right 3. Then we're going to go back to our origin. We go down 1 and to the left 3. Down 1 and to the left 3. Down 1 and to the left 3. and we can connect our dots. So you can see that that negative in front just flips it over. And that number in front, now that it's compressed, it's making it flatter, right? Because it's a fraction. Okay, let's talk about a couple things with this one while I have it here. First of all, tell me, what is my vertex in the graph I have here? 0, 0. I agree. 0, 0. The axis of symmetry. Symmetry, there we go, is x equals, because it's a vertical line, and where does it cross through x? 0. X equals 0. It's this beautiful line right down the middle. It happens to be the y-axis in this case. Okay? Questions at all in that? All right. Let's go to example 5. Oh, you got to give me like 8 or 9. I know. Example 5. Describe the transformation. And I'll just abbreviate. All right. So in problems 18 through 22, it says graph. I just want you to describe again. So the only 4 you have to graph are the first 4. Here, I just want you to describe it. So maybe you get y equals negative 1/3 the absolute value of x. Oh, I just did that one. How about 2/3? Let's do that. 2/3. My bad. All right. So the negative means we have a flip. And 2/3 is between 0 and 1, so we have a compress. 2/3. Do one more in here. What if I have y equals 4 absolute value of x? What is that one? Stretch 4. Very good. Example 6. Example 6. This will be 24 through 28. On 24 through 28, it says, without graphing, identify the vertex, the axis of symmetry, and transformation. All right. So here we go. Let's say I have y equals 2 absolute value x plus 5 minus 3. So the easiest thing to do is to start with a transformation. So we'll start there. Okay? The 2 in front, stretch 2. Inside the absolute value, I have x plus 5. Left 5. Good. Down 3. All right. My vertex. If I go to the left 5, where am I ending up? Negative 5. And if I go down 3, where do I end up? Good. Negative 3. My axis of symmetry, which we're going to abbreviate AOS, is x equals. What does x equal? Negative 5. It sure does. Do one more underneath that example. Same deal. Let's say we have y equals negative. I'm going to throw a trick at you. 5 over 4, x minus 3 plus 2. Flip. This is the trick. It is a stretch because it's bigger than what? Good. It's a stretch of 5/4. Now what? Good. Right 3. Up 2. What is our vertex at? 3, 2. Good job, Seth. 3, 2. Anybody have a question where he got 3, 2? Okay. And then our axis of symmetry is x equals 3. Perfect. All right. I think I can get away with one last example. Example 7. Thought you guys liked to hear me talk. All right. This is similar to number 30. Write an equation for an absolute value function given a stretch of 2, left 6, and up 5. Very good. X plus 6 plus 5. Absolutely. This is our stretch in front. If we're going left 6, remember it looks like it's opposite in here. It's x minus a negative 6. Gives us plus 6. And then we have up 5. Now the only difference is in number 30 in your book, they give you a picture of it. So you got to just look and see where's your vertex instead of me saying left 6. You got to do the same thing. Okay? Any questions? Yeah, I'll get the rest of the graphs back in a second. Okay? Well, there is some graph paper up here if you prefer that. We are only doing